Are GMOs safe? A molecular geneticist speaks out. Written by Stacy Malkin. This is part 1 of our interview with Professor Michael Antoniou. Part 2 is here. Are genetically engineered foods safe? In an interview with a leading molecular genetics expert, we discuss the scientific evidence behind health concerns tied to genetically modified GM, corn and pesticides, how GMOs are changing in ways that increase health risks, and how regulatory systems have failed to keep pace with modern genetics. Professor Michael Antoniou, head of the Gene Expression and Therapy Group at King's College London, has studied for more than 35 years how genes function and how they are disrupted. His decades of rigorous independent research into the risks of GM foods and glyphosate-based herbicides have raised serious concerns about the safety of these technologies. In a report he prepared for the Mexican government, as the country attempted to restrict GMO corn imports for health reasons, Professor Antoniou cited a large body of evidence from well-controlled laboratory animal toxicity studies that show evidence of harm to multiple physiological systems from toxic agents found in GM corn. In this interview, Antoniou explains that the health risks of GM corn and its associated pesticides arise from 3 main sources: but insecticidal proteins engineered into the plants, DNA damage caused by the genetic modification process itself, and pesticides used on the crops. He warns that today's stacked trait GMOs, which combine multiple bee toxins with resistance to several herbicides, have never been properly tested for safety, even though animal studies cited in his work show signs of liver, kidney, immune, and digestive system damage from earlier single-trait GMOs. Evidence suggests bait toxins may survive digestion, enter the bloodstream, and trigger immune reactions linked to allergies. Antoniou also highlights findings from his research showing that mixtures of commonly used herbicides, glyphosate, 24D, dicamba, even at regulator-approved exposure levels, caused organ damage in rats. He concludes that regulatory systems remain stuck in outdated assumptions, ignoring both the risks of stacked GMO traits and the combined toxicity of pesticide mixtures to which people are routinely exposed. Stacy Malkin, your testimony for the Mexican government cites many types of evidence that indicate the potential for serious negative health outcomes from eating GMO corn in the very high amounts typical for Mexican citizens. Could you tell us, what are the most concerning health effects showing up in the studies? Prof. Michael Antoniou. Before going into detail, we should realize initially there are 3 possible sources, minimally, of toxic outcomes from the consumption of not just GM corn, but GMO foods in general. First is the product of the foreign GM gene, the transgene. In the case of GMO corn, the insecticidal proteins, the bee toxins, have never been an integral part of the human diet, especially in the special form they have been engineered into the crop. They can pose a risk of toxic or allergic reactions. Secondly, the GM transformation process, the process by which a GMO is generated in the laboratory, is highly mutagenic. What do I mean by that? Inadvertently, you create unintended damage to the DNA of the crop. Much of this DNA damage remains in the final marketed product. What is the danger from this? DNA damage can change the function of multiple genes, not just one, but many genes. And by changing the pattern of gene function in the organism, you will change its biochemistry and its composition, including the unexpected production of new toxins and allergens. Third, regardless of the GMO crop we're talking about, they're all grown with one or more different kinds of pesticides, mostly herbicides such as glyphosate. So they invariably come with pesticide residues, especially glyphosate residues, another source of potential toxicity we will discuss later. So these 3 elements are sources of possible toxicity from the consumption of GMO corn, which the Mexican government objected to because they were concerned about risks. Related reporting. Stacy Malkin. I want to get into particular health effects you're concerned about, but first let's discuss how GMOs themselves are changing. In the U.S., most of the corn and soy we grow is genetically engineered as both insect-resistant, bee toxin, and herbicide-resistant. Can you explain how these stacked trait GMOs are increasing concerns about the types of DNA changes you're talking about? Prof. Michael Antoniou. Yes, a very important point here. In the earliest days, first-generation GMO crops had one or two different bait toxins in them, and the early safety assessments were based on the single trait, a single bait toxin, or glyphosate tolerance, and rightly or wrongly, they were passed as safe using various criteria, which were completely inadequate anyway. What's happened over the years is that, as insects have become resistant to the early bee toxins that were engineered into the corn, companies have added more variants of bee toxins into the crop, up to 6 now in some varieties. In addition, you've got not just glyphosate-tolerant genes, but up to 3 different herbicide-tolerant genes added on top of that. You would think the regulators would say, we're dealing with a completely different animal here. You'd think they would reevaluate from scratch. But I'm afraid that's not what's happened. What regulators have done, no doubt, what industry has convinced them to do, is that if a GMO crop was passed as safe with 1 or 2 bit toxins in it, it was assumed that when you combine more traits into one crop, there is no additional risk. Well, I'm afraid that is not science. That's just assumption. The direct evaluation of the toxicity of these stacked varieties of GMO corn have simply not been conducted. It's not as if they did the research to convince themselves that that was the case. It was a purely hypothetical assumption to avoid doing any proper health risk assessment. This is very worrying because even with the early generation GMOs, especially corn containing at most 2 different varieties of bee toxin, multiple well-conducted laboratory animal feeding studies, including studies conducted by industry, show signs of toxicity in the animals, especially pertaining to kidney and liver structure and function, but also to the digestive and immune systems. Consistently, in studies conducted by independent academics, but even upon close scrutiny of the industry data submitted for market approval, even in relatively short-term, 90-day feeding studies, you saw biochemical changes in the blood indicative of liver and kidney dysfunction. This is with bee corn containing just 1 or at most 2 varieties of bee toxin. Now imagine what can happen if you amplified that with 6 different varieties of bee toxin in one crop, and on top of that added the glyphosate tolerance and other traits, glufosinate, 2,4-D, and dicamba tolerance. You're going to have up to 6 different bait toxins and multiple herbicide residues all in the same foodstuff, and the direct evaluation of the toxicity of these stacked varieties of GMO corn have simply not been conducted. It has just been assumed by regulators that we passed this Roundup glyphosate-tolerant corn as safe, and this bait toxin corn as safe, and when we combine them together, we think it's still going to be safe. But I'm afraid this is not on the basis of science. It's on the basis of pure speculation. And it ignores the fact that these single traits of either bit toxin corn or glyphosate-tolerant corn, when assessed in these rat toxicity studies I was referring to earlier, both of them showed signs of liver and kidney damage, structure and functional damage particularly, and that is based on relatively short-term feeding studies. So if you were to extrapolate going longer term, which unfortunately was never done, then it's very worrying that these could have escalated into very serious health outcomes in these animals. Stacy Malkin. So what are the consequences for human health? And do we see evidence of these types of problems in humans increasing since these foods have been on the market? Prof. Michael Antoniou. Well, again, this is a very good question, but unfortunately, there have been no human epidemiological studies to try to correlate increases in GMO food consumption and negative health outcomes in, say, the U.S. population, where they are consumed in quite large quantities compared to some other parts of the world. So we don't really have an answer to this very important question. There are very solid animal feeding studies in mice and rats that show that bit toxins are highly immunogenic. What we do know is that there are incidences where people have reported allergic reactions to the consumption of a bait toxin corn in the United States. See the Starlink corn case. It was quite some time ago now. The Starlink bit toxin corn was meant for animal feed, but it inadvertently ended up in the human food supply as well. There were some reports from people who said they had an allergic reaction. We shouldn't find this surprising because there are very solid animal feeding studies in mice and rats that show that bit toxins are highly immunogenic. What do I mean by that? They will elicit a very potent immune reaction in the consumer. That lays the foundation for developing into an allergy. So the fact that some people perhaps had this reaction after consuming Starlink, I don't find surprising, and there could be many more people. As you know, in the United States, food intolerances, especially allergies, have skyrocketed in recent decades, especially since the launch of GMO crops and foods in the US. Has that contributed to the rise in food intolerances and allergies? This is a valid question to ask, which needs to be addressed formally. I can tell you that pediatricians I know in the United States, whose families bring their sick children with food intolerances and allergies, once they move them to organic whole foods diets, slowly but surely they got better. But is it the GMO food or pesticide residues present in GMO and non-GMO foods? We cannot be specific, but the possibility is there that it could be exposure to these bait toxins. It was assumed by regulators, without conducting proper testing, that the bait toxins would break down. You digest them. They wouldn't cause any harm. It turns out that bait toxins, especially in the form in which they're engineered into the foods, can survive the digestive process, and you can find elements of them in the bloodstream of people. And who knows what the health implications of that are? It's going to cause an immune reaction for sure. Could that escalate into a food intolerance and an allergy? For me, these are perfectly plausible outcomes that need to be addressed. Stacy Malkin. We've talked about how GMO foods have been changing, but regulations are still stuck in the 90s. One change is that, as weeds and insects have evolved around GM crops, companies have been genetically engineering plants to resist multiple herbicides at once, not just glyphosate, but also 24D and dicamba. Tell us about your research on the toxic effects of combined pesticides. Prof. Michael Antoniou. Inspired by this change in GMO cultivation in the U.S., we conducted a rat feeding study exposing animals to a mixture of glyphosate, 24D, and dicamba. Exposure began in mid-pregnancy to reflect a more real-world exposure scenario and continued until 13 weeks after weaning. The level of exposure was at the acceptable daily intake of each of these three herbicides in the European Union, a dose of each of these three herbicides that regulators say we should see no adverse health effects. We clearly see that the livers of these animals are suffering oxidative stress damage, and in the kidneys we're finding even more pronounced structure and functional damage. My group is in the middle of a very extensive analysis of the gut of these animals as well. I can't go into too much detail because it's unpublished work, but I can say that it doesn't look good for the animals. The key thing is that the level of the glyphosate was at the European Union acceptable daily intake in this mixture, half the acceptable daily intake in the United States. We didn't see profound health outcomes. But when we mixed that level of glyphosate with the 24D and dicamba, we saw the most pronounced negative health outcomes. This is showing us how regulators are failing to consider combinatorial toxicity. We're not just exposed to one chemical at a time a day. We're exposed to tens of different pesticides every day through our food, and that's added to other toxic chemicals from other sources in the environment. So minimally, again, regulators must come of age and start to consider the mixture effects of pesticide and general chemical exposure, and not just glyphosate alone. In part 2 of our interview, Professor Antoniou explains how new scientific techniques, known as omics methods, raise new concerns about GMOs and pesticides and show that GMO crops are not equivalent to non-GMO varieties.